Türkiye döküm sektörünün değerli temsilcileri, bir eğitim etkinliğine daha başlıyoruz. Hoş geldiniz. TÜDOKSAT Akademi eğitimleri webinar ve seminerler şeklinde devam ediyor. Gene bir webinarla karşınızdayız. Bundan önceki webinarımız yapay zeka ve dijitalleşmenin döküm sektöründe yeni perspektifleriydi. Oldukça geniş katılımlı oldu, ilgi gören bir webinar oldu. Ee, Bundan sonraki webinlerimiz gene dijitalizasyon konusunda üretim ve data analitiği ile ilgili dijitalizasyon çözümleri. Bu eğitimimiz gelecek hafta 18 Mart'ta. Bunun duyurusu da bugün geç saatlerde yayınlanacak. Ee, Bu şekilde devam ediyor. Şimdi ben sözü Sayın Konuşmacı'ya vermezden önce genel kurallarımızdan bir kere daha bahsetmek istiyorum. Sunumun sonunda bir anket olacak. O ankete cevap vermenizi istiyoruz. O ankete katılarak belirteceğiniz görüşler bizim için yönlendirici oluyor, katkı sağlıyor. Olası engelleri önceden tespit edip tedbir alma imkanı veriyor bize. O birincisi. İkincisi, aşağıda chat box dediğimiz sohbet kutucuğu var. Lütfen sunum boyunca ve de özellikle sunum sonunda sorularınızı oraya yazın ki biz de o soruları uzmana soralım. Daha önceden duyurulduğu gibi bugünkü sunum İngilizce olacak ama ekrandaki görüntüler, paylaşımlar Türkçe olacak. O konunun daha kolay anlaşılmasını sağlar. Daha önce denedik, başarılı sonuçlar aldık. O nedenle biz FOSECO'daki arkadaşlardan bunu Türkçeleştirmelerini istedik. O şekilde devam ediyoruz. Şimdi bugünkü uzmanımız Avrupa'dan özellikle ürün müdürü tabir ettikleri maça boyaları konusunda bir uzman. Maça boyaları hepimizin baş ağrısı biliyorsunuz. İyi uygulanmazsa veya hatalı uygulanırsa veya doğru seçilmezse. Bu refrakter maça boyaları ile ilgili iyi uygulamaları FOSECO'nun Avrupa ürün sorumlusu Sayın Romelczyk'in sunumunu yapacak. Ben sözü kendisine vereceğim ve kendisini tanıtarak sunumuna başlamasını isteyeceğim. Roman, could you please present yourself briefly and then start with your presentation? Thank you.
Yes, thank you. Good afternoon to everybody. My name is Roman Romelczyk'in. I'm come from Poland, and some additional words about me and my you can say career. I would say like that. So between 1998 and 2003, I finished in Technical University in Poland. Just immediately after Technical University, I start work for aluminium foundry for 5 years, different positions. And from this foundry, FOSECO grabbed me, we can say. And since 2008, I work for FOSECO and again in the different positions. I started as an application engineer and just, we can say first 3 years, another 3 years, I was also application engineer, but in a greater region. I was responsible also for east part of Europe, countries like Russia or Ukraine. After this, another 3 years, I was promoted to be a local product manager. That time we had a production at Poland, coatings production and slips as well. Since 2019, again, I was promoted to position of technical manager. So I take care about all product lines which FOSECO have. Currently, again, I'm promoted and for new position as a European product manager. Currently, I cooperate very closely with Christoph Gensler, who still is with us. So yeah, the region is whole EMEA. What's more, okay, I'm happy father of 2 daughters, so it's me. Thank you. So I can start. Understand?
Please.
Yeah. So today I would like to talk about the coatings. We can say from the beginning to the final one. So when we talk about the casting defects and what we can do with it. So first, I would like to talk about the naming itself, what kind of coatings we have, the types and carriers and other the things. So as you can see that coatings can be alcohol-based, water-based, can be dedicated for different application methods, and also the different, we can say, different alloys and the different mass production or more jabbing production. So isomol tenor coatings, as I said, alcohol-based, whole coat, Semco, Riotec, and another, we can say, family of Semco seals. All of them are water-based, and as I said, different application methods as a brush, spray guns, dipping, flow. So all possible applications. We also can talk about special coatings, which are dedicated for example, for green sand molding to improve the surface of green sand if any problems happened with green sand recipe. Also, for these special coatings, we can put in the same group some coatings from Semco, Zir group, and Tenor coating group. Yeah, as I said, I would like to talk about these coatings from the beginning. So first, we can say I would like to say talk about what the coating is. So what is in the recipe? What kind of chemicals, what kind of materials are used to create the ready-to-use coating? So the first and the most, we can say, important, it's a liquid carrier. As we said, water or alcohol. Alcohol can be isopropanol, ethanol. In some countries, we can also see the blends alcohol, so between ethanol and also isopropanol. Very rarely, but still happened. We also have some coatings in base of methanol. Of course, in Europe, in our region, it's cannot be like that from safety reasons, from environmental reasons, so it's banned and blocked. The next one, it's a suspension agent. It means that it's a special, we can say, materials or chemicals which prevent sedimentation of solids. So the solids like zirconium, corundum, aluminium oxides, and other, they are more heavier than liquids, as water or alcohol. So this suspension agent take care about hanged their solids in whole volume to not sedimentate. Another one is binder. Binder, it's we can say part of the coating which take care about the coating in a dry phase. So it means after application, we dry the coating and we expect from the coating some mechanical strengths. So when we talk about even like adhesion, but itself mechanical strength as well. So to prevent, for example, powdering or peeling off. So it's also responsible for it, it's binder. Dispersion agent. This agent take care about the coating during the time. So as produced, put it on the warehouse or to transport somewhere far from the production site. So we need to be sure that the coating during this time will not change a behavior, not change your rheology or thixotropy behaviors. So this dispersion agent take care about that. I already touched the filler system, solids, refractory solids. We will touch this point later. Wetting agent, also very important point. Wetting agent, it's nothing more than chemicals or materials which take care about the wetting angle. So we can imagine that we have PUCB cores, furan, alkaline phenolic, or other, which for which is used also release agents, which is fatty. It means that it's not always easy to cover by especially water-based coating. So this is why this wetting agent improve or they care about that this wetting agent, wetting angle will be enough to cover surface everywhere in the same, and build everywhere the same layer thickness. When we talk about alcohol-based coating, of course, this kind of wetting agent not exist because itself alcohol have very small, it depends of the literature, small or very big wetting angle, so it's no problem with it. Anti-foaming agent for both alcohol and water. During the mixing, during the usage, during the circulation, dilution, and all of these manipulations, we mixed sometimes very turbulent coatings. So this part of the coating create the foam and the bubbles which will be trapped in the coating, in coating itself. Rheological additive, this is we can say super important part. This part of recipe take care about the wet layer thickness, about drops, about tears, and all the things which is connected with coating layer built on a core or mold. Biocides are only for water-based coatings, because in water-based coating during the time, the anaerobic bacteria can grow quite fast if it's infected. So this biocides, two types. The first one is like antibiotic. So we can say it will take care about the bacteria during the time, longer time, but also it's a part of some kind of immediate killer of bacteria to be sure that the coating is free of bacteria for storage, ready for storage. So when we talk about solids and refractory, yeah, it's the main one, of course, the most popular, it's zircon, corundum, magnesite. Between that, it's graphite, iron magnesite silicate, so some kind of olivine, and that kind of, it's very, very popular. Also, as an addition, we use coke. We use some with a lower refractory point, mulite, silica as well. So this is the main raw materials which I believe, I'm pretty sure that you are, we can say, familiar with, and you work on daily basis with it in your foundries or in your just daily work. Yes, so this is a part of the coating, and the big question is for what we use a coating, why we use a coatings. So when we talk about the defects, so the coating itself cannot cover the mistakes of mold or core, preparation of mold or core, but can help and support the surface finish. So that kind of, we can say, problems like burning, metal penetration, veining, it's a special group of coatings which have this anti-veining properties. Of course, some gas defects, lustrous carbon, and more others. Even some kind of not a filtration, that's like a grabbing. If we talk about the furan mold process, the coatings are able to catch sulfur, which can, we can say, affect nodular iron, the surface of casting. So many defects can be improved by coatings. So coating itself in a quite big magnification or zooming looks like we can say on the pictures. Left side we can see the layer of the coating. Right side is of course it's a mold. In the right side of the slide we can see on some other coating, more flaky. We can observe also some penetration, so the coating is sucked by mold by capillarity effect inside to impregnate the layer. So it is like how it looks like. Yeah, application methods. Quite important slide because in this slide you can see the same coating. So four pictures, what you observe, it's the same coatings. This coating it's differently applied on the same mold with different viscosity, because it's obvious that for spraying, brushing, dipping, and flow, for each of these application methods, main one, viscosity of the coating, so automatically density as well, it's different. So for flow and dipping, the coatings are more diluted. It's around 12, 13, 14 seconds. When we talk about the brushing, it's around 20, 18. It depends what kind of raw materials are used for coating. When we talk about zircon, which is roundish shape, it's quite easy to brush. If we talk about olivine or magnesite, it's not that easy for brushing. This is why we need to dilute more. So it will be some kind of 18 seconds measured by DIN cup for millimeters. When we talk about the spraying, it depends of the equipment what we have, coating, what kind of you use. So the viscosity is quite a big range. It's between 14, 18, even 20 for airless system as well can be used. So, and what we observe, what we observe in the pictures, different viscosity, different application methods, and to look how different is the layer, wet layer thickness built on the mold or core. So the best we can say for us to prevent metal penetration or burning on that kind of defect, of course, it's a left side of the slide when we have a quite nice penetration, and the layer itself is also nicely built. When we talk about the right side, it's less penetrated, but layer also enough to prevent some kind of defects. The next one, when we talk about the how to select the coatings, so which base from raw material point of view, from solid sides, can be used for what kind of alloys. So it's not that complicated, but still we can find some problems with it. But in general, for steel, we will use solids, raw materials with high refractory behavior, like a zircon, magnesite, aluminum oxides, and corundum. When we talk about gray iron, of course, if we want, we can use what is used for steel plus some graphite. Heavy metals, we will focus something around graphite, coke, silicates, magnesium silicates, zircon as well. Aluminiums, graphite, coke, magnesium silicates, and of course, the last one, zircon and aluminum silicate. So we can see that the zircon is most popular from possibility to use, and with some other mixtures, we can say, because when we talk about the coatings, not always is like that, that if it's, for example, coating dedicated for steel, it's only zircon inside. It can be mixture between zircon and corundum, or can be also for special usage, can be mixed for gray iron or for nodular iron if it's needed. It will be mixture between zircon, olivine, and graphite as well, or coke. So many big number of possibilities, we can say here. Yeah, the same, we can say this is another way to show how looks like the mold with high magnification, and the different raw materials as a main one in a coating recipe. From the right side, we have aluminum silicates, magnesium, graphite, zircon. So we can observe that the penetration is different, the shape of the grain size is different, shape of grains are different. So it will give us different properties in a final stage. So we know now a bit about the recipe, we know about the application methods, we know a bit about the raw materials which we use, so solids itself, refractory solids. And now I just will switch for the usage. So what kind of very often observed some kind of mistakes during the application. So of course, what I already explained, if it's the coating is not properly selected, very important is that because you have a chance to see the recipe itself, that it's 10, 11, 12 different materials mixed together with different weight, with different density. So it's obvious that this coating always need to be super precisely mixed before use to be sure that all materials are mixed together and they have a chance to work together. So this is a observed mistake, that it's not properly mixed. What's more, I will touch this point later, but it's very often it's also that the coating during the preparation and after the application, it's not controlled. So viscosity, density, bome, wet layer thickness, dry layer thickness, because wet layer thickness and dry layer thickness always will be different, because shrinking during the drying. So if the carrier will disappear, of course, it's obvious that the coating will shrink a bit. What's more, this is not with reason. These pictures are put here, that the mold or core just after the coating is applied. Now we talk about alcohol-based coatings. Just after application, the mold or core is set on fire. So it means we don't wait any minutes, 10 minutes, half an hour, but immediately we will burn out. It's a quite big mistake, and I will try to say and show why. That's it. Another very important, when we need to apply 2-3 layers of the coating, very important is that the coating is applied wet on wet to prevent scabbing, to have a chance to give a chance that the coating will, with each layer, will stick together very strongly. So advices is nothing more that opposite what I show before. So we need to mix, we need to control, we need to take care about wet on wet, this layer application, wet on wet. Drying by flame, but really if it's needed, this is the first point. Another one, if it's needed, don't rush, don't be hurry with it. Wait some minutes to give a chance to finish some kind of matting time, so the mold core stop shiny. So it means that the alcohol disappeared inside. The core or mold was sucked by core or mold and evaporate a bit, and after we can burn out, put on fire. Why? Because if it's, we can say, this coating disappear inside and outside, evaporate a bit, the energy which will be created during the flaming will be less. And in the picture, you can see the bridge. This is a binder bridge between the grain size. And these binders bridges are killed and damaged by fire. So this is not exactly the picture which show us that it's an influence of fire, but this is only to give you a visual, we can say, effect, how the bridges looks like. And if we destroy these bridges, it means that the sand cannot stick together enough strongly. Tools which can be used very easily everywhere on the foundry. So we talk about the left side, top, it's a comb for checking the wet layer thickness. Very often it's also used to check dry layer thickness. We need to scratch a bit, but it's not super precise, but still it's able to check and compare wet with dry. Pictometer, very simple tool. For this pictometer is also needed balance, small balance, and we can, I don't know, we need 2-3 minutes to know exactly what kind of density we have. Fourth cup, DIN4, this is a 100 milliliter cup, and we can measure very quickly viscosity. Bomme, it's a measurement, some kind of between viscosity, density, and also rheology. So Bomme, it's still in use, but for foundry usage, Bomme, it's quite unprecise. For production and QC lab, it's useful. For foundry, give a guidelines. It's not super precise, but still in use, and it's possible to survive with it. Yes, so coating in use, and very shortly about laboratory research and alcohol-based coating, and put on fire or flaming the coatings, drying by flame coatings rapidly. What will be the effect? So this is only give you the flavor, how the research looks like. Sorry, excuse me. So we talk about Furan process. It was prepared more than 100 bars, strength bars. 90 of them was used for it. And as you can see that all the samples was taken 8 hours after modeling. So it means that the samples was prepared during the time, especially for this usage. So it means that each bar which was checked in a transverse in the machine was exactly in the same curing stage of the process to be super precise when we talk about the readings. So these samples was covered with different coatings. It was ZKX. ZKX is nothing more than zircon-based coating. It's an impregnation coating, which impregnate only the core or mold. It's to prevent, we can say, to improve refractory behavior of the core or mold. After was apply ZB16, also zircon-based coatings, and the same, but in a water base. Each, as I said, each of course, these bars was taken after 8 hours. So after 8 hours, coating was applied. It was scheduled which coating, how it's dry on the air, in the oven, or by flame. And the results of it, it's put it here on this graph. So here, when we talk about the left side and the colors of the bars, so we talk about different application method. It's a flow, spray, and brush. We can expect that you remember that viscosity of different methods are different. So amount of alcohol in the system is also different. But if we talk about drying, so you can see that below bars, you have a 20 minutes drying, 12 hours drying in ambient temperature. And the last one, it's put on fire. So we can see, and the green light, it gives us the reference strength. So strength after this 8 hours. So the first 3 bars show you what is the effect of alcohol to these binder bridges. So alcohol have a direct influence to create some kind of jelly consistency of the bridges. So the strengths go down. When we talk about 12 hours drying in the ambient temperature, alcohol have a chance to evaporate. Jelly form of binders, we can say, go back to the normal one. And why it's a more than green one? Because curing process have a chance to finished. Because for curing process, we can talk that 24 hours, this is a full process of curing. When we talk about alkaline phenolic, furans, or PUCB, we count like that when we try to research anything. So here we can see that the process of curing have a chance to finish, and alcohol, what was destroyed by alcohol can grow up again. And the right side of the graph show us that if it's coating is applied and immediately put on fire, we can say original strength, it's cut at average by 2. It's less than half strength. So it means that the surface of the mold or core, it's super soft. When we talk about quite massive core or mold, we will not expect big problems. But if we talk about high temperature alloys, and this, we can say, surface are damaged, we can expect some scabbing, some penetration, because the strength of the surface is not enough. When we talk about the thin section of cores or molds as well, we can imagine that the original or wanted strength of the core will collapse, will be very weak. And we have a chance to have breaks, veining, and that kind of defect. For more, it was put at here different coatings, as I said. Whole coat, it's a water-based coating. Another, it's alcohol. Another, it's a penetration coating. It's been that it's super diluted, 12 seconds DIN 4 cap. This is a mixture, Z kappa X, so penetration coating, and external one. And the same in the right side, but different drying method. So always, if we talk about self-drying, 24 hours, strength are higher than original green one. When we talk about in oven, it's also chance to have a quite nice strength. Another one, 12 hours, what we already discussed for alcohol base. It's better than original green one, green line. Mixture between Z kappa X and ZB16. Only when we talk about self-drying 12 hours, it's, we can say, close to the expected and original strength. If we talk about the last one, this is another, we can say, a way, but still, as you can see, that the strength is divided by 2, more or less. So this is how the drying process of alcohol-based coatings are super sensitive, and it's very important to understand that the time, it's very important here. So more time between application and put on fire, better for core mold and finally for casting quality. Yeah, so conclusions from this research or studies, it was already presented to you. So not immediate set on fire. The best we can say solution is a self-drying, or use oven for drying. If not, leave the core or mold as long as possible to self-drying. Yeah, some words about packaging and also application equipment. So first of the most popular are barrels. Barrels can be different: 200 liters, 600 liters, 50 plastic 150 liters, 25. Of course, this packaging way, it will have influence for storing time. It will have an influence, what is obvious, for price itself. When we talk about the left side of the slide, stainless steel containers with dedicated mixers. Currently, we can say this is the best solution to be sure that everything is fine with coating during the time, during storage, but also during usage, because you can put dedicated special mixer through the lid of the container, mix properly, because as I told you, mixer it's designed especially for that kind of containers, this shape. That we also, it's possible to have some kind of timer that you don't need to take care about the timing of the mixer, but the timer will do it by itself. So you can be sure that always when you use a coating, it's ready to use. Application methods or equipment for application, quite popular. This is airless system. So this the prepared and diluted coating, it's pushed by high pressure through the special nozzle. So no atomization. It means that we don't have dust and fumes around when we apply the mold. Disadvantage of it is that it's a super productive way of spraying. This is why if we have a complicated shapes, pockets and that kind of things, holes, it's not always the best choice when we talk about the application. It's dedicated for big molds, quite easy shapes. It's really improved productivity and time needed to apply the coating layer. To show you how the airless looks like in a real life and how productive is, you can see on the movie. So no dust, no fumes, long distance between operator and the mold. This mold is half prepared, and this is a final layer of the thickness to cover all scratches, mistakes, and like that. So it's as you can see, very easy, and the layer is applied very fast. In the right side, it's exactly the same mold, but top part. The first layer was applied by flow, and the final, to improve the wet layer thickness, the final layer was applied by spray gun as well. You can see how it looks like and how precise can be, and fast as well. This application gives you a chance to apply some kind of 1.2, 1.3 millimeter of the coating, just that fast. Yeah, and now it's applied some kind of 0.25 average, very fast. That's it. Another very popular and very good, from my opinion, application method, it's flow. and doesn't matter. It's a matter, but we can manage it by membrane pump with compensator. We can manage with special equipment, which is visible here in the left side, the green barrel. It's nothing more than a special barrel which pressurized coating and push through the nozzle, which this guy keep it in hand. So for that kind of application method, it's a special designed recipes with long flow to give us a chance to have a layer thickness without drops, tears, and constant level of a layer or whole mold. The difference between top part of the mold, what is visible on the picture, and the bottom part, if everything is prepared correctly, the difference between, of course, will be, but usually it's some kind of 50 microns, sometimes 100 microns. It depends on the size of the mold. But in general, this is a super fast and very, very good application method used for, we can say, dedicated for complicated shapes, with when we expect very high refractory resistance, so the coating have a chance to impregnate the mold. We can apply 2 layers of, as I presented before, first layer by flow, second by spray. So this application method give us a big chance to have a nice quality, casting quality. How it looks like, I also prepared a short movie. This is the process itself. It's alkaline phenolic. The produced castings in a base of hot-filled steel. So manganese one. Yes, alkaline phenolic, and the coating itself, it's especially designed, of course, for flow, and it's in base of magnesium. So it's a pure magnesium coating, magnesite coating. Big mold, 1 layer applied for this mold, and it takes less than a minute to apply the coating on the mold. Yeah, what's more, we also probably a lot of us, a lot of you heard about ICU idea. It's an intelligent coating unit. In general, this unit will take care about the coating preparation. So it means we deliver, or it's delivered coating in a container. Another part, it's a thinner, so water from the system or alcohol from another container, IBC, plastic one, for example. We join these 2 containers to this equipment, this unit. Unit will dose as delivered, coating as delivered, in a calculated amount, alcohol or thinner, we can say, water or alcohol, mixed together in a preparation tank, and the density and viscosity which you want to have, you put it on the LCD screen in the touch panel, and the unit itself will take care about give you exactly coating which you expect. So if you put 1.25 gram per cubic centimeter, unit will prepare for you exactly this value. As you can see, it's a different solution of this idea. ICU Pro, it's we can say all put it in 1 unit. So it's the full type, also with ATEX regulation. So you can use it for alcohol-based coating, super safe with all features, archive, GSM controlling, intranet, internet, everything can be archive. Archive can be, oh, it's a good point. Archive can be consumption of coating, consumption of water or alcohol, what is the history of density, the periods of the unit. So when was a preparation, when was a usage, when was a circulation, what was a checking, we can say level. Everything can be achieved. Put it in a history, and for example, manager somewhere in an office can connect directly to the machine, upload the data, and observe what's going on with parameters when we talk about the coatings. Another solution is ICU continuous, exactly the same, we can say, usability, but in different way. The checking it's we can say continuous. So the preparation tank can be used also as a buffer. So it's a more universal one. Another ICU modular. So it means it's as a car in a saloon. So you have a basic we can say version, and we can add for you what you want. This feature when we talk about UV treatment of the water, double filtration on one-way filtration, membrane pump 2-inch or oversized 3-inch. So you can have a chance to exactly what you want to have, and you will use in the future can be put in the machine. And ICU integrated, sorry, very nice solution. It means that you don't have some kind of preparation tank, but the brain of the system is put directly in the deep tank. So you have some pumps for circulation. It's also connected coating in the right side behind the wall. You can see the coating and the container with the coating. Thinner, it's water here. So water is from the system. It's prepared batch of coating in the deep tank, and during the usage, system take care about to prepare another small batches to keep exactly the same level, setup level in the deep tank. So for 8 hours, 10 hours, that doesn't matter, as you want, how long you want. Yeah. Some examples of usage and from real life. So we can say case studies. So here we talk about pure zircon-based coatings. ZKX, maybe you remember, this is a penetration coating, impregnation coating, which we can say improve quite deeply because it's more than 7-8 millimeters deep the refractory of the mold or core. Prevent also the penetration possibility, metal penetration possibility. And ZAB16, this is a coating which build the external layer. This layer will face directly with molten metal. This is, we can say, normal problems which we can find in foundries. If something is, we can say, not correct, or the casting itself, it's, we can say, difficult to manage, because in some cases it's also like that, but it's that difficult that it's quite not easy to manage, to have casting without defects. But left side, this is how looks like a mold after ZKX application. So it means that the layer is not builded. The normal viscosity for ZKX is between 12 and 13 seconds. So it's a consistency of milk. So very diluted. Everything needs to disappear in the mold. The right side, just wet on wet, it's applied for the ZKX is applied ZB16. Here is an example how ZKX work. So the right side, you can see that the structure of the sand is still visible after ZKX application. And the left side, the core is especially broken for this picture to observe how deeply this zircon flour can impregnate the core, and how strongly can we can say work to prevent metal penetration and improve refractory. Of course, I mentioned it here also, 9770p tenor coating. It's give you the idea that it's possible to have a water base, this impregnation coating. And what's more, these impregnation coatings can be zirconium and corundum. And why? Because when we talk about zirconium, in some, we can say, situations, zirconium can be the reason to create a phyalite defect. Because in we can say chemical formula, you can find silicates, and they give you a chance, and the whole chemical, we can say, formulas give you the idea why it's happened, and the phyalite itself can be created. When we talk about corundum, it's a more neutral from that kind of perspective. So we use corundum when we can be sure that we will not start the phyalite creation. So this is why both of minerals are used for this impregnation coatings. This is only several pictures how the casting can look after, we can say, some improvements, some changes, without any burning. You can see that the casting were not machining, not grinding by machines. It's just simply after shot blasting. What's more here, I can say that if you see these pockets on the core, originally it was used chromite sand for it, but because of usage of impregnation coating, these cores were made with fresh silica sand. It was a Furan process. Silica sand, it was used Z kappa X, so impregnation coating, normal zircon top coat, and we were able to receive that kind of results. So the way of usage and understanding what is what and what kind of problems can create, it gives you a chance to eliminate or to reduce the costs of the process. Yeah. So when we talk about some defects and some way of how to prevent or how to react for the defects. So penetration. Of course, we know exactly how it can be created. So that the core or mold, it's not enough strong. The coating was broken because the mold was broken, because metallostatic pressure pushed the liquid metal inside, but the liquid metal can, we can say, go into the porosity of the mold and create that kind of defect. So when we talk about how to, what is the reason, we can say it's some reasons on the coating side. Some reasons can be located also from mold or core side. So even that kind of points as a quality of the sand, reclaimed sand, binder itself, addition of binder, application of the coating or coating itself, the layer was enough or not, impregnation coating was used or not. So solution in a right side. So what I exactly tell you now, so how to prevent is exactly to do that. We need to use exact and good selected coating. We need to take care about the binder addition, apply pre-coat. Pre-coat, it's this impregnation coating. But what I need to say about impregnation coating, and it's quite important as well. Impregnation coating, it's not dedicated for normal usage, so for all time. Only in cases if it's a super difficult casting and we don't have a chance to change anything from mold, mold or core shape or materials. So I would say that it's a super difficult we can use for normal usage. But if something's going on with binder itself, we switch from summer to winter one binders or opposite. This times very often give some troubles. So for that kind of periods, to buy some time to have a chance to work with recipe of a mold or core, you can use to help and to support the quality by impregnation coating. So this pre-coat coating. So this is like a medicine to buy time to react to have a time to react in some process mistakes. Okay, another one, coating inclusions, of course, a lot of, sorry, I need to change, yeah. Coating inclusions, a lot of possible root causes as a high speed of molten metal. So we can say turbulent flow, velocity as well. Also the venting. Yeah, it's correct. The venting of the mold or core. And of course, the running gates and mold itself, if it's destroyed somehow, it's crushed in the running gate itself, it's not properly covered by coatings. So the molten metal during a high speed can take some particulars from the mold wash and agglomerate, locate this washed part of core or mold somewhere in the castings, what is visible on the picture. So to prevent it, of course, it's opposite what I say. We can calculate once again the runner system. So redesign, use a different way of application of the coating to be sure that it's adhesive and sticking. It's enough to take care about the running gate itself, that it also should be covered by the coating. So many possible solutions. Another one, it's also very popular, it's burn-on. It's as always, we can find alloy from reclaimed sand, it's too high. The mixture ratio between fresh sand and reclaimed sand, it's not correct. Some other the parameters of the sand is not correct. Not properly mixed and use a coating. The layer of the coating, it's not enough. In some cases, it need to be used, as I explained, chromite. If not chromite, we can think about use it's a facing sand only from fresh sand, not mixture between reclaimed sand and the fresh sand. So many possibilities to improve the situation with burn on. Of course, it's also you can use a pre-coat to help and improve the things. Another one, pinholes, another type we can say. So when we talk about gases produced from binder system, gases produced from reclaimed sand, also from drying process is not properly dry, mold or core. All the things can give you that kind of pinholes. Also some, we can say, gases give you a chance to create chemical pinholes like a nitrogen and that kind of things. Solutions, of course, opposite what I said again, everything needs to be checked, controlled, redesign if it's needed. Of course, here is also very important the venting give a chance and a way to escape gases from the we can say cavity area. Gas accumulation, very close to the previous one. Some of the, we can say, solutions are similar. So venting, permeability of the system. So permeability is connected with sand grain distribution. So how it's big or not, what kind of dust content is. So this very fine part of the grain size distribution is very important because they are blocked quite strongly permeability, additional of binders, and all the things which give you, we can say, an effect that the gases are trapped in a cavity, and finally in castings. It means that these gases will not have a chance to escape through the coating mold, through the vents especially created. Yes, the final one, not final, but very often happened mainly in automotive sections, or maybe not automotive, but mass iron production, veining. And veining, it's coming from the sand expansion, and it's the sand mold and core expansion, mainly sand expansion, also additional rate of binders, more heavier effect of it because it's more stiff. So expansion will create quite easily the gaps, the breakage. To prevent that, you can use special additives to create the space for this expansion. You can use a special coatings and different recipes. The coatings which will, we can say, have a chance to cover the breaks. So the mold or core itself will break, but the coating will be able to still keep the liquid metal away from this breakage, and the metal will not go into. What's more, veining itself, we can say that it's a beginning of penetration, and it's we can say depend of the situation and how the metallostatic pressure is, how big the casting is as well. You will, in the first period of time, we will have veining, and just after, if it's a bigger casting, longer time for solidification, so the molten metal is super liquid, it's pushed into the core, we will have a metal penetration. As I partly explained, solution use different sand the sand grain distribution, special coatings to reduce these tensions and expansion in the mold or core. Another, it's a coating scabbing, and again, it's connected with many cases from mold and core. Again, gases, permeability, the surface quality of mold or core, release agents used for it. Maybe, for example, it can be too much, and it give you an effect that the coating not adhere enough. So adhesive between the coating and the core after drying, it's not enough. So it means during or after casting, liquid metal will be not enough to keep the coating into the mold. Gases will remove, it's like explode the coating from the surface, and the coating will flotate on the liquid metal and create that kind of defect. To prevent it, vent, grind size distribution, permeability, different coating, applicate coating wet or wet, take care about the release agents. Yes, it was the last one. Thank you very much. This is a contact to me and also to Urbey, my friend from, we can say, Turkish team, technical manager. Thank you very much.
Thank you. Thank you, Mr. Romelczyk'in. It was a very informative presentation. Hopefully all participants got benefit from this very detailed presentation. We know that 1 hour is not enough to discuss all topics at one.
Yes.
but the examples at the last minute examples about casting defects was quite informative, let me say. When you say pinhole, there are too many reasons. You can list other reasons there, but those are the ones you have listed are directly related with the coating applications. That is good. Let us keep this page here because I'm sure if there are some detailed questions, they will get contact either with Urbey or with yourself with the contact info at the bottom with your emails. Now participants are answering the questionnaire, what we are asking about, did they get benefit? Is something perfect or wrong? That is this kind of info. So we are waiting them to write down questions on the chat box. At the same time, I want to ask you a few questions. One of them is,
yes, please.
Are you classifying the coatings according to their permeability character?
Yes,
Normally,
of course.
we are believing that coatings, core coatings are not permeable, gas permeable. Is that not correct?
Yeah, it's correct. And what's more, in some cases, we would like to have, we can say, as much as possible high permeability. In some cases, it's need to be blocked as much as possible. And to give you a more explanation, when we talk about the most possible permeability, of course, we talk about full mold process, that kind of processes. When we expect with 2-3 millimeters layer thickness of the coating, we still expect that the flexibility and permeability of the surface of the coating will be enough. When we talk about turbocharge, made with high alloy steel, and we talk about PUCB way of core preparation, or even hot box or shell box. Here we would like to block permeability as much as possible. When we talk about cylinder heads or blocks, we will be somewhere in the middle. So we need to have some permeability too, because when we can imagine cylinder head, it's a super complicated shape, and a lot of we can say a lot of gases need to have a chance to escape somehow. So partially it will go through we can say some kind of vents, partially will go through the coating, through the core, to the core prints, and go out somewhere. So yes, permeability of the coating, it's one of the very important parameter. And for each coating, we are able to prepare a special way of checking of this permeability. Different laboratories can differently check it, but some of them are quite uniform or unify. That it means that the way of checking of permeability, it's very similar.
Thank you very much. That was interesting. Arkadaşlar soru yazmanızı bekliyorum. Sohbet kutucuğuna en başta sunumun başında söylediğim gibi sizin sorularınıza cevap verebilmek için ilk soru geldi. Devamında diğer soruları da görürüz. Roman, are you able to see the question or should I read it?
I don't
If
see
you
any
if you
question.
if you click on the chat box down there, chat box at the
Yes.
bottom, yes, you will see the question.
How? Okay. Tunabay. Hello, something. How can we avoid from metal penetration on manganese steel without chromite using alpha acid resin molding? Yeah, in some cases we can choose. It's a quite tricky not question but process, because manganese steel itself it's super difficult. Even with alkaline phenolic, with good quality sand, sometimes even with olivine sand give us some problems. But what I will propose, so of course take care about the grain size distribution, how it looks like, that some finer part of, we can say, of the grain size distribution need exist. So it means that the porosity of the mold and core need to be enough to prevent by self the metal penetration. But when we talk about manganese steel, it's not only physical penetration, but it's also chemical. So some reactions give you that the wetting angle of metal, it's not good for us. It means that it's give a chance to penetrate. So to say like that, I will go for to try to use impregnation coatings, and two of them. It's not that problematic to use both of them. Zircon one, it's a 30 micron grain size and smaller, and corundum as well. It's more neutral from chemical side. In the past, for main parts for stone crushing machines, we use Z kappa X, so zircon one, and manganese top coat. It improve the casting results, but not eliminate fully the problem with penetration. If we have that kind of problem, it means that the whole package, we can say it's not perfect for this mold, for this casting of this alloy, the mixture between the sand quality, grain size distribution, chemistry of it, even the binder addition, everything collect together and give us a problem. But for now, the most quick and easy, try to use impregnation coating.
Uğur Bey, katkın varsa yapabilirsin. Mikrofonunu
Yok,
açtık.
okey. Yani Roma'nın açıkladığı gibi tabii bu bize çok gelen sorulardan bir tanesi. Manganlı çelikle ilgili özellikle işte biraz daha işte maliyetleri düşürmek amacıyla işte sanıyorum o amaçla geldi soru. İşte silis kumu yerine, işte kromit kumu yerine manganlı çelikte işte silis kumunu kullanarak neler yapabiliriz şeklinde bir soru olarak algılıyorum bunu. Roma'nın da bahsettiği gibi işte bizim özellikle kendi ürünlerimizden bahsedecek olursak işte magnezyum oks, magnezik bazlı bizim boyalarımızdan bunun üst katman olacak şekilde altına da bizim kalıp boyası dediğimiz ince taneli boyalarımızı uyguladığınız zaman üzerine ufak bir katmanla işte 5 bina dediğimiz Roma'nın da bahsettiği boyamızın uygulanmasıyla burada yüzeydeki bu penetrasyonları, bu silis kumundan dolayı oluşabilecek riskleri aslında elimine edebiliyorsunuz. Uygulayan dökümhaneler var. Arzu eden, daha detaylı bilgi almak isteyen birisi olursa mutlaka bize ulaşırsalar kendilerine destek olmak isteriz.
One addition, Urbey, if I may.
Yeah,
Also,
please.
it's worth to try that if you use some kind of coating currently now, it's also good to check, because it will cost nothing for foundry. The first layer of the coating dilute more to prepare some kind of 14 seconds to impregnate the molten core, wait some half an hour, and try to apply the top coat. So we will have a chance to impregnate the surface of the mold, prevent and block the porosity, prevent the chemistry as well, or yeah, prevent, blocked the chemical part of this game as well, and the top coat minimum 0.3, 0.35 wet. So it gives you a chance to build a proper layer of a coating, magnesite coating.
Yeah. Good, Roman. That was also I was trying to explain. Yeah, this is another option. Yeah, thank you. Any other questions?
Evet, başka sorumuz varsa yazalım arkadaşlar. Yoksa ben ikinci bir soru gelene kadar bir soru daha sormak istiyorum. Roman, you have given an example about the scabbing defect on the
Yes.
casting. Possibly your example was on the cord surface, isn't it? But the scabbing is mostly seen on the mold surfaces.
Also, yeah.
Yeah, also, especially at the wet molds, when the strength is less, and mostly seen as a big headache for the founderman scabbing defects. Your advice to prevent scabbing defect on the cord surface, what was the main measure that you proposed for cord surface on the coating side?
You know, one super important point is to right selection of the coating, because as I explained after your question about permeability, so if we will have a coating with this group of low permeability coating, it means that the gases which will push or try to push a coating on the surface of core or mold will be blocked by this low permeability, and gases will have a chance to remove the coating, explode the coating from the surface. So this is the first point. We have a chance to play with permeability, to select different coating or right coating. This is the most critical. From other hand, of course, all the mold and core, it's a producer of gases. And whatever we do, the gases will exist. But we can take care about how many gases will be produced. So we can manage by binder addition, by refreshing the sand, grain size distribution to take care about permeability itself, the mold and core permeability. Take care about not cover the core prints, for example, when we talk about the cores. When we talk about the molds, use steel pins to create the holes on the mold to give a chance to create some kind of chimneys for gases. So it's moving around the different possibilities. Some of them need to be covered some research, some laboratory research to understand where we are with molding mass, where we are with grain size distribution, the quality of reclaimed sand if it's used. So many things are in the game.
Thank you. Thank you for this quite precise information that will be beneficial for the founderman. It seems that there isn't any more question. So we expect that everything is understood well. If there are some further questions, you are the candidate who will answer the questions properly, precisely later on.
Yeah.
We thank you once more, Roman. Last words.
Last words from me. I'm
Yes.
super glad and happy that I have a chance to present this presentation and have a chance to give you some answers. If anything was not fully clear, sorry for that. My English is not perfect, but not hesitate, not be blocked. Send to me or Urbe email, contact with us. We will be super happy to have a chat with you, to have a contact with you, to discuss with you. And of course, if it will be possible, we will help. we will have. So once again, I'm super happy to have a chance to present this presentation, to have a chance to speak with you. Thank you very much.
Thank you. Thank you. Evet arkadaşlar, bir sonraki eğitimde buluşmak üzere diyeyim. Bize bu webinarın oluşması, Polonya'dan bir sunucunun gelip bize böyle detaylı bilgi vermesine vesile olması nedeniyle Uğur Bey'e de ayrıca teşekkür ederiz.
Ben
FOSECO
teşekkür ederim.
ailesine bu vesileyle. İyi günler, sağlıkla kalın, hoşça kalın. Bye bye.
İyi günler.
Thank you.